Hi everybody, in this video we are going to go through some fun-filled problems that might serve you well on your homework assignment. And we might be using this table as a guide. Okay, here's our first problem. Here we want to find all the values of theta if theta is in the interval between 0 and 360 and the sine of theta is equal to negative square root of 3 over 2. Okay, before we do this, let's go ahead and actually draw out our Cartesian plane. Okay, there it is. Okay, now in quadrant 1, we know that sine is positive, right? So whatever angle we have is not going to be there. In quadrant 2, sine is still positive. Okay, so we're not going to have anything there either. In quadrant 3, sine is negative, and in quadrant 4, sine is also negative. So we know that we will have an angle here, okay, where the sine of theta is equal to negative square root of 3 over 2. And we will have an angle here, where once again the sine of theta is equal to negative square root of 3 over 2. Now, if we go to our table, we will notice that the square root of 3 over 2 occurs when the angle is 60 degrees, when the sine of 60 degrees is square root of 3 over 2, and that actually is our reference angle. That tells us that theta prime is equal to 60 degrees. That means that this angle right here is 60 degrees, and that this angle right here is also 60 degrees. So if this reference angle is 60 degrees, then this entire angle is going to be 180 plus 60 degrees, or 240 degrees. So our first angle is going to be 240 degrees. And then our second angle is going to be, which is this right here is our actual angle, but if you'll notice that, this right here is 360 degrees, minus 60 is going to give us 300 degrees. And so our second angle is going to be 300 degrees, and that would be the answer to our problem. Those are the two angles where the sine of theta is actually equal to negative square root of 3 over 2. Now you can actually verify that just by using your calculator. So here's my calculator. I can do sine of 240, sine 240. It gives me that. Okay, that happens to be equal to the negative square root of 3 divided by 2. Okay, I didn't do the negative side. You can just imagine it's there. And also the sine of 300 degrees. Gives you the exact same answer. So that can give you some confidence that you do indeed have the correct problem. Now our next problem is going to be to find the tangent of an angle in degrees, minutes, and seconds, and then the cosecant of an angle in decimal degrees. The tangent is relatively straightforward. The only thing that we need to do is convert this to decimal degrees before we can actually put this into our calculator. And this is going to be equal to 68 degrees plus 43 divided by 60 degrees. Okay, and then we're just going to go ahead and compute the tangent of that. We can actually do that in one shot. We can do that as tangent 68 plus 43 divided by 60. Close that parenthesis using your mouse over here, and then hit enter, and that right there is your answer. Now they want this to 6 decimal places, so we want to write this out to 7 decimal places. That's going to be 2.5670735. 2.567073073, and then my 7th decimal place is 5. I wrote this out to the 7th one because the 7th one determines how I'm going to round. And since my 7th decimal is 5 or higher, I need to round up. So this is going to round to 2.567074. Now here, I want to find the cosecant of 35.8471 degrees. Okay, there's only one side problem. we don't have cosecant here. Okay, we only have sine, cosine, and tangent. So I need to make use of my reciprocal identities. And with the reciprocal identity I'm interested in is that cosecant is equal to 1 over sine theta. So this is going to be equal to 1 divided by the sine of 35.8471. And the way we can do that in our calculator is sine 35.8471. Okay, there we go. We get that, and then just take the reciprocal. By clicking that button, that's going to take the reciprocal of our previous answer, and that is our cosecant. Once again, we want this to 6 decimal places, so I want to write this out to the 7th one. So that's going to be 707,579. My 7th decimal place will be a 6. So this is going to be equal to 1.707,5796. 5796. So this is a 6. So we need this is greater. This is obviously greater than 5. Okay, so we need to round up. So the 9 is going to round to a 10, which means this is going to become a 0, and we're going to carry a 1. So our answer is going to be 1.707580. Now for this one, we want to find the angle in the interval of 0 degrees to 90 degrees to the nearest degree, whose cotangent is 1.4466474. Okay? Now, to do this, we are going to use what we call the inverse trig functions on our calculator, because we know what the cotangent is. So we can use that to figure out the angle. And our calculator, I'm going to show it to you right here. Once again, it has our trig functions, and up here are the inverse trig functions. And we will actually talk about these in more detail. But right now, what you need to do is that if you actually have the value of a trig function, these will give you the associated angle. The only problem is that you don't see cotangent here. You only see inverse sine, inverse cosine, and inverse tangent. Okay, we don't find inverse cotangent. However, if we know the cotangent, we can figure out the tangent. The tangent of theta is going to be the reciprocal of this. So the tangent of theta is going to be equal to 1 over 1.4466474. And then theta is going to be the inverse tangent, or also known as arctangent, of that fraction right there. And that's what we need to compute. So let's go ahead and do that. There's a variety of ways to do this. One of the ways you can do that is just do second inverse tangent. There we go. 1 divided by 1.4466474. Close your parenthesis, hit your answer, and that is your angle. Your angle is going to be equal to 34.6 degrees. 34.6 degrees. Remember, we want this to the nearest degree, so I went to the decimal. This is, once again, 5. This number is 5 or greater, so we need to round up. This is going to be 35 degrees. Okay, and our last problem is an application. And as you know, if you probably don't really appreciate this on an automobile, but you would appreciate this if you're riding a bike. If you are biking uphill, it takes a little bit of work because you actually have a resistance due to the force of gravity. And if you're going downhill, you can actually really cruise because you actually have a boost due to the force of gravity. The force is basically governed by this. There actually is a fair bit more to it, but right now we're going to keep things simple and keep it like that. So we want to calculate F to the nearest 10 pounds for a 5,500 pound car going uphill with an angle of 3.9 degrees. So what is that? Well, that means that F is going to be equal to 5,500 times the sine of 3.9 degrees. Okay, and what's that going to be? Well, let's check our calculator and find out. That is going to be 5500 times sine 3.9. Close that parenthesis, hit enter. There you go. We have that F is going to be equal to 374 pounds. 374 pounds, but keep in mind we want this to the nearest 10 pounds. Okay, so we want to look at this. Now here, my unit here is less than 5. Okay, so we don't need to round up. So this is going to round to 370 pounds. And that will be your answer. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.